Hey guys, in this video we're trying to build a small app which can chat with documents using Langchain. We'll be trying out a few flows using Faiss, Pinecone and ChromaDB, but any flow that we follow, we'll have to go through the same flow diagram. We'll be following these steps in much detail and we'll be trying them out too. But before stepping into that, let us have a small glimpse on what we're trying to build. So this is a con call report of a company called TCS. So this is more like a discussion between the business executives and the interviewers where they discuss about the company growth prospects, the revenue and future growth plans and so on. So instead of going through all of the document, let's see if we can answer all of our questions using AI. You can see I have just logged a few page loads and let us ask few questions. So the first thing I want to know is how is the profit of the company. You can see the AI has analyzed the document and it has come up with what is the net income margin and what was of the full year, and I want to know how was the revenue as well. And one more thing I want to know is how many people work in the company. You can see it has come up with a number, and let's cross check the same from the document, and you can see it exactly matches with what's there in the document. And one more interesting find is you can see the way the question was framed. What we have asked it was how many people work in the company, whereas what's there in the PDF is more like what is the resulting closing headcount of the company. So you can see the questions are quite different, but it was smart enough to analyze the context of what we're asking. So this looks quite cool, but let's start diving in how to build this. Here you can see the code base is pretty small, which is why it's pretty important to understand what exactly these functions are doing. So we will just go through the flow diagram to understand the same, and just giving a heads up that I might be sounding to going quite fast, but don't worry, we'll be again coming back to this and comparing with this with the code step by step. So here the first thing we're doing is having a PDF, which is the input of our function. So once we have a PDF, we're going to extract the text, and the extracted text we are going to separate into multiple chunks of data, and these chunks we are converting it to embeddings, which is what AI understands. And for this we are using this OpenAI. And once we have all the embeddings of all the chunks of the data, we're storing it in a separate DB. So this DB can be any vector DB, it could be Pinecone, it can be ChromaDB, or it can be something in your local. So once we store all of our vectors embeddings in a vector storage, we can call this as a knowledge base. So this knowledge base is something where we have all of the data, and any question that a user asks or what we ask, the AI searches all of the context from this database. So now that we have this vector stored data, any whenever any user asks any questions like we have asked about the profits or so on, it again is converted into an embedding because it's a question. Again, we are using OpenAPI for this, and then it does a semantic search of any context that it can get from all of the embeddings it has stored in the vector DB. So once it has found out the same, it will rank some results. So there might be many paragraphs that might suit the context of the user has answered, but so it will rank all of the compatible or semantically correct paragraphs. And once it has fetched all of those, it uses the OpenAI's LLM again, and then it will analyze what is the correct answer from it, and it responds to the user. So I might have again sounded to have gone quite fast, but don't worry, we'll go through the code and analyze the same. So to follow this, we might be using a few or multiple ways. So one is Faiss, Pinecone and ChromaDB. These are nothing but what we are using for the vector storage. So I'll be covering one or two of them, and other things you can just cross check from the GitHub repo I'll be sharing in the video. So first thing is Faiss. So Faiss is more like um, a vector storage which is offered from Facebook. So instead of buying something, if you're just trying out in your local, you might not have to buy something, a vector DB storage in Pinecone or cloud. You can just try it out with Faiss so that it will work just for free. So let's go through the code. So the first thing we're doing is we are importing the .env, which is where we have all our OpenAPI keys, and then we have our PDF reader where we are reading the input, and we are importing all of the Langchain stuff where we have the OpenAI embeddings, all the vector stores, and anything we'll be using in the later part of our code. So let's go through the code. You can see this part of the code is, you can say it's quite dummy, because all it's doing is launching a server and it's just running it, and any input data that a user asks, it's going to call this function, which is process input, and this again calls this chat with PDF. So the real code of what we have is just these two functions. So let's start with chat with PDF, which takes the input. So even before we call the chat with PDF, you can see we are loading the PDF as a knowledge base. So you can see we have a PDF and it is being converted to this knowledge base, and this part is being done in this function. So let's see what we are doing here. One thing is we have the path to PDF. You can see using a library which is called PDF reader. We are going through all of the pages, each page, and then we are extracting each page. So it is a very basic code of Python where we are taking the file as input. We are checking how many number of pages that the PDF has. We are looping through each of the page, and then we are getting each of the page and extracting its text. And we have a global variable, or you can say a functional variable, which is of type string, and any data that's being extracted from the PDF from each page, we are appending to that PDF text. So this is being invoked in all of the files that we have, because any flow that we need to extract the text from it. So I have separated it as a separate file, and we are importing it. So here we are invoking that function, and because all of the text is extracted and appended to one single string and it is being returned, here is where we have all of the PDF text that we have extracted. Now that we have all of the text from the document, we need to split it. If you remember, after we have the PDF, once we extract the text, we need to separate it into chunks of text here. So to execute these steps, we're using this text splitter. So this character text splitter is again available in Langchain as well. So we are just importing it from the Langchain, and here we have few parameters that we are passing it. So one thing is the separator. If we want to separate it on each line, or if you, depending on the use case, if you have something more, or you have some symbols that you want to have a separator to it, so on. But in our use case, because it's simple, I'm just choosing each line as a separator, and there we have a chunk size. So in the PDF we might have millions of characters or thousands or so on, but because we are trying to separate them in chunks, we need to specify the Python file that how many characters that each chunk has. So as of now I have specified as 1000. So all of the thousands of characters are split into different chunks, and each chunk has a character size of 1000. You can change it again as per your use case. And then we have is chunk overlap. Chunk overlap I have set it as 200. So chunk overlap is something um, let's say all of this comes under one chunk of text and is of 1000 characters. uh, just so that to make the context very relevant, even the next, what we are doing with the chunk overlap is, even in the next text, even in the next chunk, we are using some data, we are appending some data which is of the previous chunk. So assuming all of this is one chunk, so the next chunk starts from here instead of here. So though all of this is one paragraph, though this and this might be separate, the second chunk will start from here, just so that we can have some context between all of the chunks that we have. Again, you can choose to keep it as 0, or you can choose to keep it more depending on the use case. Length function is something we are just specifying what is the length function of the Python file. It is len, so we are just passing the same. So now that we have specified all our parameters, all we have to do is just run it. So we're using this text splitter and we are splitting the text, and we are passing the huge text that we have, and what we have in the return is we have the chunks. So just for your use case, let me just print it out. First thing I'm printing out is the PDF text, and another thing I want to print it out is the chunks that we have separated. So let us run it again. So I'll just search for the chunks here. So before the chunks, we have printed the PDF text which has all the text from each of the pages. If you can see it from here, 10th page is the 9th page, so on. And then we have printed all the chunks. You can see it's an array, and all of the text data is split into multiple chunks with an overlap. So let's remove this log and let's see what next. Now that we have the chunks of the text here, the next thing we need to do is we need to convert these chunks of text to embeddings. So here you can see we're using the OpenAI to do that. Let's see how to do that. So the next function that we have is OpenAI embeddings. This is again an ready to use module imported from Langchain. So we just import that, we have these embeddings, and then we convert a knowledge base using these embeddings. So we have an empty embeddings which is imported. To convert it into these embeddings, we are passing the chunks that we have just split into, and then we're using this library. So this is where the different flows quite differ. So here we're using Faiss, and we have some more called Pinecone, ChromaDB, and so on. As of now, just to make it easy to use and to make it free of charge, I'm showing a demo of the library which is launched by Facebook. So alternatively, you can choose the other Pinecone and ChromaDB as well. We'll have a brief walkthrough on that as well. So as of now, what's important is we have the text, we have split that into chunks, and then we have it embeddings. Using both the chunks and embeddings, we have converted into an embeddings with OpenAI, and now what we have is the knowledge base. So this is again a module launcher from Langchain. We can just import that and directly use it. So now that we have the knowledge base, all the user has to do is make a query. Any question that he has, he need to check if there is some context, any semantic context similarity present in the knowledge base. So comparing to this flow diagram again, have the PDF, we have done this part, we are done with splitting into chunks of text, we are done with converting into OpenAI embeddings, and we are done with converting these embeddings and storing them in a vector store. As of now, we don't have a DB, we are just using the library. In the next part of files, we'll be using that as well. But you can see the flow diagram might sound quite complex to you, or it might sound it might be doing like it is doing a lot of stuff, but if you see the code, we are doing all of this stuff in just 4 to 5 lines of code. So that's how easy it is. And now that we have everything, let's just use the knowledge base and do the rest of the part. So the rest part is more like the user asks a question, and this question is embedded, and again this is semantically searched through the vector DB. All these results are ranked, and then the OpenAI LLM analyzes the ranked results and gives the answer to the user. And even this part is very much simplified in the code. You can see even the chat with PDF has very few lines of code, and all of that is done with a very small set of functions. So here query is the user input. He might be asking what was the profit in the knowledge base, and here what we are checking is in the knowledge base we are doing a similarity search. So similarity search is more like it automatically converts it into OpenAI embeddings, and then it does a semantic search on the vector store depending on the question or the input the user has given. So now that the user has given a query which is the input, and this question is semantically searched in the knowledge base, we discussed that it will give us a list of ranked data, which is more like the ranked ranked outputs, where we which is of a similar context of the vector store. And all these docs, we are going to pass it to the LLM of the OpenAI, because there might be a lot of paragraphs that might kind of sound relatable to the context of user's input, but we might have to analyze the OpenAI has to analyze all of this data, and it has to come up with an answer which exactly answers what the question has asked. So here we have the LLM that we are choosing. You can choose any LLM you want. If you have trained some data in your local, you can use that as well. But since OpenAI is free and it is pretty smart, we're using that as an LLM. And again, all these are freely available and readily available in the Langchain library. You can just import it, and you can see there is a load QA chain function to which we are passing an LLM that we have selected, and then we are selecting the chain type as stuff. So once we have this chain, we just run it with all the input documents, which is the ranked results that we have, and the user questions. So depending on that, it will come up with a response, which is what the output is. So all of it is running in just two functions. So if you see the server, whenever it loads, we are loading the document, we are creating the knowledge base, which is what the first function is doing, and then we are checking if the user has anything to ask, any input data that user enters. We are just calling the process input, which is invoking the chat with PDF, which is the second function that we have. So all the code base is just with the two functions. One is initializing the knowledge base, and second is querying that knowledge base that we have already created. So this is all we have. So again, just to show you, let's run it again, and then we'll just try it out with the Pinecone on ChromaDB. So let me initialize it again, because we deleted all of the log there. So what was let us ask some different question. What was the discussion about? You can see it's saying the discussion was about TCS financial results for the fourth quarter, and so on, about the revenue growth, operating margin, and so on. So you can see with one library without any uh, charges we are able to use this. And just so that for your reference, we are using the library that we're using is this Faiss, which is developed by Facebook. I'll be posting this link so that you can directly access this, but you don't specifically need to install anything. It's totally directly available from this module. So this is one way to do it, and there are a few other ways, and you can choose, as we discussed, you can choose thousands of ways to do this, which is why I'll be just going on a very much brief on what are the other ways that we can achieve this. So another thing is this pinecone.py. So here, instead of having a cached data, we're using a vector DB. So here in the flow diagram, if you see, they're using Pinecone. So it's more like a DB. So usually if it is a JSON or text, we use MongoDB, PostGRE or MySQL and so on. But now that we are converting all the text into embeddings, and all these embeddings might need to be stored somewhere, we might need some proper DB. So Pinecone is one of the many DBs that we have. So in this example, we are using this Pinecone. So just mentioning that whatever the first file that we have, the process is complete. We have done these two files, that is done, and now this is one more way to do this. So first thing you might have to do this, you might have to go to this Pinecone website, and you might have to create some OpenAPI keys. I have created one for mine, and you might have to go to the Pinecone website and create one for yourself. And you might have, once you do that, you might have to mention it in your environmental variables, just so that your app can access this and reach out to this server. And for the starter, they give few projects or just one project for free tier. Anything more you want, you might have to buy it, and you can see the pricing in the app website. So now that we have this, let's create an index. I have deleted whatever I had for me, so I'll just create one whatever I already have. So I am just creating one index called Langchain stuff, and I'll be creating a dimension for it. If you see in the code, it's already mentioned 1536, so I'll just follow the same. So anything more from the starter, it is chargeable. So it is, you can see it's S1, P1 and P2. Each of it gives us few of the features, but right now we'll just go with the starter for the demo, and just click create index, and just giving a heads up that any database that you create in free tier, it will get expired in 7 days. So make a note of that. So now that our index is created, you can see the monthly cost is 0. The vectors we have is again 0. And this cloud is hosted on GCP, and the region that is selected is Singapore. And so on. There are other details on replicas and all, which you can choose to upgrade or downscale or upscale the same. And there is a lot of metrics that we can choose to analyze. But as part of the demo, we'll just concentrate on just creating and storing the vector DB and fetching the data. So in the Pinecone data, if you see, it is kind of similar to the older file that we already had. So this is again the dummy data, which only concentrates on loading the data. Launching the server and taking any inputs. And again, there are only two functions that do most of the part, which is chat with the PDF and initializing the server. So again, I'll just briefly go through it, because most of the flow diagram and the code is kind of similar to the previous file or previous way that we followed. So here we have imported most of the libraries from the Langchain, and then we have some environmental variables one is the open key, which is open API key, which is by default. And if you remember, we just discussed that we need to create few files, few environmental variables when we go to the Pinecone. So we might have to specify that in your local environment variables, and you might have to import the same. So now that you have all the environment variables initialized, you might have to specify the index. So index is what we have created it here. It is the Langchain stuff. You can choose to name it accordingly. Then we import this Pinecone library. And you can see we have just initialized it with the API key and environment that we have. Now that we have done with all the initialization of variables, we'll just dive into the functions that we have. So the first part is loading data to the Pinecone. So before user queries any data, we might have to initialize the data. In the previous example, if you remember, we are not storing the data anywhere. We are just initializing it. We are initializing the knowledge base. And once the server stops, all the data is gone. But in this use case, we do not want that. So assuming you want to build some chatbot, which you might want it to remember some chat that has been already done like 4 or 5 days back, even the server is stopped and restarted, you might want to still persist the data. You might have to go with this flow where all of the data is stored as embeddings in some vector DB. So which is why we're using this Pinecone. So for this to happen, we might have to load all of our data into the Pinecone database, which is what this function is doing. So you can see it is taking the path of which file it needs to load. And just like the same example as before, we are just invoking this function which takes the PDF file and converts it into PDF text. And just as before, we are splitting the text that we have into chunks. We are specifying the chunk size, what is the overlap. I'm just for understanding purpose, I'm choosing different values from before. And this splitted values, we are creating documents. Again, all of this data, splitted data, is converted into embeddings, which is into chunks. This chunks is nothing but the text splitted into different an array of the whole PDF data, which is split into multiple chunks, an array of chunks. And then just like before, we have the embeddings, and there is something called dimensions which we might have to specify. You can specify your own dimensions depending on the use case. In our example, because it's a starter, I'm just specifying 1536. You can follow the same. And I might not go through each of the conditions, but you can see here we are creating an index if the index name is already not present. So here you can see the Pinecone lists all of the indexes that it has, and then it checks the index that we specified is already present or not. If it is not there, it will automatically create an index. Otherwise, it will just go to the else part and it will load it from whatever is existing. So you can see the function just ends there. So all it does is it just like what we did before, it takes the PDF, it splits into chunks, converts into embeddings, and loads it into the DB. And here you can see there are two ways we are initializing the docx. One way is we are calling this invoking this from documents. So what from documents does is, because the index was not already present, just because we just created this one, it will initialize even the embeddings and store it in the DB. So here we are doing the storing part of the PDF, and here we are we're not storing any of the data. So here we are saying that everything is already present, the PDF is already loaded. So I do not want to load it again. I do not want to make a put request or save the same data into the same server again. So we just load whatever is existing in the DB. So that is the first part of the function, and the second part of the function is chatting with the PDF, which is the querying part. You can see it is again very similar to the what we did in the previous file. Okay, and so we'll just try this out. I'll just copy this function for the first time here uh, because I don't have any data and I have just analyzed it, and the index is already present, so it will skip it here. In your case, you might not have to do anything. So instead of calling the previous file, I'll call the other file that I have, which is .pinecone. So it's asking the query. I think I might have missed some part here. If you see here, I miss the loading part, and I might have to specify the file I want to load it. So we'll use the same file. We'll save the file that we used before. So I'm loading this file and saving it to the DB, and then I'll be making some queries. So I'm calling this file. You can see it is split into chunks, and if you see here, it is loading it into the Pinecone, and the loading is done. Now I can ask it any question. Now let me ask, how was the profit? Just like what we did before. Oops, I think we missed something. Okay, I think I'm out of tokens. Because I'm a free tier, I don't have as many tokens as required for the PDF. I believe I'm out of tokens, but I guess you got the point I'm trying to convey. So just like the same previous file, we're doing the same thing. Here, the first function we are loading and initializing all the data, and second function we are querying from the data that we have already initialized. The only difference is in this file we are loading data to the Pinecone, which is the database, instead of just using some cache data. So even if the server is down, you can still access some other day with all of the data. And here in the second file, instead of just using all of the embeddings and just doing the similarity search directly, here if you can see, you're using the Pinecone, and you can pass, there are multiple other parameters apart from the index name. So you can choose multiple indexes with different kinds of data. So one where you can store books, or any other thing you can store your website data or anything. So based on the index name, you can get all of the embeddings, and that from there I think it's very similar to what we did in the previous file. If we compare it to the previous file, this is what we were already doing. So we were already doing the similarity search, which is a semantic search, and then we were creating this LLM, and then we have the chain which analyzes all the ranked results and gets the response to the user. And if you compare it to what we're doing with the Pinecone, it is kind of totally similar. Only difference is the embeddings that we have is fetched from the database. It is fetched from the cloud. So even if the server is just started, even if the data is stored a weeks or months or years back, you can still access and analyze the same data. So this is the file with the Pinecone. So here you can see the files. I'll be sharing the repo. You can just try it out. And there is also one more file with ChromaDB as well. You can try that too. And there are few other integrations that Langchain provides. Here you can see CSV talk, where you can talk the same way with CSV files. So you can chat with it. I mean, if there are some tables that you are implementing, you can ask the sum of it, how many users, or anything with anything you want to talk with a CSV file. There are many other integrations as well. So I'll be coming up with more videos on the same. And Like I promised in the last video, I'll be also coming up with a multi-agent interaction where agents talk to each other. So stay tuned. Uh, Please subscribe the video, and until then, signing off.